Hello everyone, welcome back to my SB2 channel. This video is all about the gas densities and the molar mass. They're going to be a practice for you as well. Okay, so we're going to start by the gas density first, and then I have the molar mass after that. Okay, so as you probably remember, we talked about density. We already know that density is going to be defined as m over v. M is going to be the mass, right? And V is going to be the volume. Now let's connect that to our ideal gas law. Remember that master equation, the ideal gas law equation, right? Which is PV that is equal to nRT. So what I'm going to do here is I'm going to do a little bit rearrangement. And now I have my N, moles of the gas, over the V, the volume, that is going to be equal to your P over RT. So if you look at the left side, the N over V, that is actually giving us the moles per unit volume. So it's not quite density yet, because density has to be mass over volume, right? So take a look at the next page. Okay, there are going to be more steps so that we can convert the N over V to the M, which is the mass over the V. Okay. Okay, so to do so, there are going to be a few steps. The first step is multiplying each side by your molar mass, which is a capital M. And just a quick reminder, the unit here is grams per mole. That's what we have for molar mass, right? Okay, so it would be NV, right? N over V times by the molar mass. And that is going to be equal to PM, right? That's your molar mass divided by the RT. So again, all I did here is I did multiply both sides by molar mass. Now I'm trying to recognize my density. The left-hand side, just focus on that for now. If you look at the units, okay, N is going to be the moles, V is going to be the volume. And then your molar mass is also grams per mole. So I can cancel out the moles, and that would actually give me the grams per volume. Guess what? This is your density, right? So pretty much the left side is your density. And I can replace that by D, right? That's a common letter for, density presentation. And that is going to be equal to the right side, which is P M over RT, right? So this means that the density of the gas, as you can see according to this equation, is going to be depending on three factors. The first one is pressure, right? And I have direct proportionality. So if I increase my pressure, I'm going to have higher density. The second one is the molar mass, which is also a direct proportionality. So if you have a gas that has higher molar mass, we're expecting to get higher density for that. Now, temperature is in denominator. So that would be an inverse proportionality, right? Or you can say indirect relationship. So if you increase your temperature, we're expecting to get lower density, okay? I hope that makes sense. Okay, so my friends, we already know that we have a very cool equation for calculating the density, which is including the molar mass, right? So now I'm going to take you to the next step. I'm going to rearrange my equation and I'm going to isolate that for my molar mass, which is going to be dRT over P. Okay, so everybody take your time, think about this equation. You can calculate the molar mass, right? If you have the density of the gas. So we actually can measure the density experimentally. And when you do that, you know exactly what is your temperature and what is your pressure. That means you know everything, right? You know everything on the right side. You can plug them in and you can calculate the molar mass. And that is so cool. That is so helpful because if you know the molar mass, number one, you can identify the gas, right? And you can pretty much connect your gas laws to the everyday life, such as the fire extinguishers, your hot air balloons, right? You can use that for like predicting different things in our weather forecasting. This is something that is very helpful. Okay. That's a cool science that you actually see that in your daily life. Okay. Excellent. So we have a practice. Follow me on the next page. Okay, so here's the practice, and holy, it's a lot. Okay, so we have to like carefully read that, and then I'm going to give you a listing of all of these information on the next page. Okay, So we've got a large evacuated flask and it has a mass of, as you can see, 134.567 grams. When the flask is filled with a gas of unknown molar mass, so it seems that we are looking to identify what is this gas, what is this mystery gas, right? The pressure is given and you also have your temperature, right? The mass is given as 137.456 grams, okay? Now, there's another experiment which is done with water. And again, you have the pressure, you have the temperature, and it says that we have 1067.9 grams. This is for the water experiment. We also are given the density of water. Now, the question is, what is the molar mass of the gas, right? And it also says that you can apply your ideal gas law equation. That means you can treat the gas as an ideal gas. Okay, so let me show you all of these details that are given here on the next page. Okay, so here's a nice summary of all of these details. You've got the mass of the flask, right? Then we have the mass of the flask plus the gas. So if you subtract the flask, you can get the mass of the gas, right? You can do the same thing for the water experiment. So the mass of the flask plus the water is given. When you subtract the flask mass, that is going to give us the water mass, which is given here. Okay, the other thing that is given and is so important, right? It's the density of water. And as you can see, it's always specified at a specific temperature because remember we said if you change your temperature, we're going to get different density, okay? The pressure is also given in the units of K Pascal, right? And always turn your or convert your temperature to Kelvin, right? And according to the units that we have here, this will be the proper units for your R, right? Universal gas constant. Okay, looking at the next page. Okay, so the first step is what is the volume of the flask? Okay, that's the volume of the entire experiment. To find this out, I can use the water experiment. Okay, so I know exactly what is the mass of water, and we also are given the density of water. So the mass over density would be your volume. This is in milliliter, which is not a good unit, right? Because it has to be like in liter according to your R units. So you can convert that to your liter. So you just need to take your 936 milliliter, multiply that by 10 to negative 3, right? That's how we can convert it to liter. Okay, so we've got the volume. Great. Looking at the next page. Okay, now I'm going to go ahead and use the gas experiment, right? The experiment that was done by the unknown gas to find out the density of the gas, right? So you already know the mass that is given. We calculate the volume. That's the volume of the flask. It was the same flask, right? They used that twice. So grams over liter, that is my density. And now I have everything. You have the density of the gas, you know exactly the temperature and the pressure. You can plug them into your equation for the molar mass calculation, and that's it. We are done, right? Your final answer is going to be 79.7 grams per mole. Okay, very good. That's it for this lecture, everybody. Thank you very much to all of you for watching this video. There are going to be a couple of more lectures for this chapter, okay, coming up soon. Take care of yourself and bye-bye for now.